I vividly remember the moment when 3i Atlas stopped being just a green dot on the celestial map and turned into something that made everything that could shrink inside me shrink. Until that day, it had been a beautiful, if almost academic, problem for us. An interstellar object, a hyperbolic orbit, a safe flyby on December 19, 2025 at a distance of about 269 million kilometers. A green glow, a strange outgassing delay, a high CO2 to H2O ratio, perfect material for articles, reports, and quiet nights. We knew its trajectory better than our own meeting schedules. We knew there was no threat. And that's precisely why what we saw in its tail was so frightening. It wasn't a collision, it was a collision with something we didn't expect. By that time, many people already knew about the comet. Astronomy enthusiasts were discussing the footage of Starfront in Texas, captured through their Celestron Rasa 8 with a ZWO ASI 533MC camera. Some admired the purity of the green glow through the UV-IR filter. Others debated its origins, saying that it was interstellar, meaning it carried the chemistry of an alien star system. But all of this was primarily optical, beautiful, and spectacular. The radio spectrum was considered a garnish. Interesting, yes, useful for molecular lines, but without the drama. That's where I was assigned, just to monitor, as the curator put it, the millimeter range in case we catch something. At the time, I didn't realize how literally he meant it. The observing scheme was simple yet incredibly ambitious. Optical and near-IR monitored the brightness, structure, and coma of the tail, while we, the radio operators, sat in the millimeter wave band, connecting to everything we could get our hands on. ALMA, several European arrays, and a couple of private antennas that had agreed to operate in experimental mode. We expected to see the standard set. CO2, maybe a bit of CH3OH, a classic spectral mess of rotational transitions of molecules, fluctuating depending on the tail's activity. For the first few weeks, that's exactly what we saw, a noisy but familiar picture fitting neatly into our cometary chemistry lectures. The trouble is, sometimes a pattern begins to emerge from the noise, and if you have enough time, enough data, and enough wicked persistence, you can't help but notice it. At first, we attributed the oddities to everything. On certain nights, narrow needles would appear in the spectrum that didn't line up with any known molecular patterns. Random blips, we thought, interference from satellites, ground transmitters, or some radar. We ruled everything out. We checked launch schedules, the trajectories of operational spacecraft, the frequency plans of military and civilian services. These needles didn't match any known table. They simply appeared and disappeared. I did what everyone does when they stare at noise for too long. I cut out a few of these anomalous fragments, converted the spectrum to the time domain, and ran it through an old correlation script we once wrote for analyzing radio interference on low-orbit satellites. I wasn't expecting anything. At best, I wanted to be sure it was white noise with a slightly odd shape. But when the first significant correlation popped up in the logs, I just sat there for a minute, staring at the date line, 1978, the frequency on which one of the old American TV networks broadcast. The spectral mask was an almost exact match. I figured there was a bug somewhere in the code. I replaced the database, changed the window parameters, did everything you're supposed to do when you encounter something devilish. But every time, even with the right settings, the same picture emerged. Within the seemingly chaotic millimeter wave spectrum of the tail, there was a pattern suspiciously similar to a filtered, time-stretched imprint of an old television signal. Not just one, not a specific program, but the very structure, the very mechanics with which we stitched images into radio broadcasts in the 20th century. I didn't immediately shout it out loud to the entire channel. First, I showed it to two people I trusted. One chuckled and said I'd adjusted the parameters to see what I wanted. The second was silent for a while, then quietly asked, "Have you tried looking for anything else, not just the TV signal?" We expanded the database. We added recordings of Cold War-era digital radio stations, old lighthouses, fragments of the first Apollo mission broadcasts, Voyager and Pioneer signals, and anything else we could find in the archive that could be considered human technological radio noise. It took weeks, but as the script digested gigabytes of old broadcasts, it returned increasingly more matches. Not perfect, not exact matches, but matches where the probability of randomness was too small to be considered serious. By this point, 3i Atlas was already entering the portion of its trajectory where its distance from Earth was decreasing. To that very 1.798 AU, and optical observations converged on one thing. The comet's activity was behaving strangely. Outgassing was lagging behind model predictions, the green glow was brighter than expected for such distances, and the carbon dioxide-to-water ratio remained stubbornly high, as if the comet hadn't noticed it was approaching the sun. All of this was discussed officially at conferences, in articles, in interviews. What we found in the tail, no one initially discussed. We had a sleepless night, closing all unnecessary windows, disabling notifications, and immersing ourselves in analysis. I remember slowly dragging the cursor across the waveform, overlaying an old BBC broadcast onto the time-aligned pattern from the 3i Atlas tail. Sometimes only general modulation patterns matched, sometimes specific audio fragments extracted through the inverse transform. In one place, where there was a pause between programs in the original, a distorted but recognizable jingle emerged from the tail signal, so distinctive that anyone growing up in the UK in the 1980s could hum it. Then came a moment I still avoid recalling in detail. I decided to test an idea that seemed outlandish even against the backdrop of everything I'd seen. Instead of comparing signals there with archives here, I reversed the process. I took the millimeter wave spectrum of the tail, stretched it in frequency and time, as is done when decoding complex signals, and began searching for any internal patterns whatsoever without reference to known sources. And I found it. Deep within the noise carpet, at a level rarely reached by human algorithms, sat short fragments, compressed to a few milliseconds, which were strangely grouped. One such fragment, after all the possible transformations, turned into a hideously distorted yet painfully recognizable fragment of speech from the far side of the moon, the very one where the Apollo 8 commander reads a passage from the book of Genesis. Only here the voice sounded lower, as if it had been forced through an alien atmosphere, and the pauses between words were uneven, as if someone was trying to assemble the speech from separate building blocks. The three of us sat and listened to the distorted voice of the man who spoke these words almost half a century ago, on a completely different frontier of celestial mechanics, coming from the tail of an interstellar comet, passing hundreds of millions of kilometers away. And at that moment, for the first time, I felt not just interest, not just scientific excitement, but pure primal fear. Not because it was paranormal, but because it was too technical. It gradually became apparent that the comet somehow knew about our radio past. Or rather, it didn't. It was somehow re-emitting what we ourselves had once cast into space. This could be explained theoretically. Radio waves emanating from Earth are scattered by interstellar dust, reflected by plasma clouds, and can be captured and re-emitted in a different frequency range by complex structures, but nothing geometrically matched here. The time delays, angular positions, power, everything was too correct. If 3i Atlas were a stationary mirror in space, we would see our own signals with a delay corresponding to the Earth-Comet-Earth dual path. But what the calculations showed looked more like an algorithm than a passive reflection. Individual fragments coincided with signals that could never have reached the comet's current position based on the speed of light. Some of them were too young; they would have arrived there only years after the flyby. Others, conversely, could have reached the comet before we even invented the necessary wavelengths. Then for the first time, a thought occurred to one of us, one we didn't want to voice out loud. What if the 3i Atlas tail isn't a mirror but a filter and compressor? What if the plasma, ionized gas, and dust, all of this combined, form a kind of physical archiver of man-made radio noise, one that doesn't simply reflect it but selects, compresses, recodes, and re-emits it in a different form? And most importantly, for whom does it do this? Of course, we didn't officially publish anything like that. The first internal report seemed cautious and understated. Anomalous correlations were identified between the millimeter spectrum and historical radio signals from Earth. Possible mechanisms include multipass scattering, nonlinear plasma effects, and systematic calibration errors. They particularly emphasize the last point. Calibration errors have always been a convenient trash can for anything that deviates from the norm. But in parallel, we continued digging. The closer we got to December 19th, the more intense the work became. We monitored not only the spectrum but also its evolution, and we noticed something else that completely stole our sleep. The structure of the anomalous fragments was changing not chaotically but according to a strange logic. It seemed as if at some point, part of the archive had been completely lost and something new had taken its place. One such day, we picked up a signal we couldn't connect to any known source. It looked like a fragment of an emergency radio transmission. Short, fragmentary phrases, lots of noise, rare technical terms, numbers, coordinates. We ran it through databases, every possible service, even the closed catalogs of space agencies, nothing. Not a single recorded incident, not a single known mission matched it. And then someone proposed a terrifying experiment, not to look in the past but to compare it with a possible future. We took model accident scenarios, negotiation templates for unknown situations, everything that was available in crew training simulators, and discovered a frightening similarity. It was as if the comet's tail were emitting a recording of a radio conversation that hadn't yet occurred but already existed somewhere in the form of a document, a protocol, a planned simulator. Of course, common sense dictated that we settle for the simplest explanation. A recognition error, an overtrained algorithm, the human tendency to see patterns where none exist. But the more we analyzed the 3I Atlas archive, the stronger the feeling became that it was collecting not only what we had already said on air, but also what we were about to say. As if it were responding not only to the actual radio stream, but also to the potential state of the man-made shell around the Earth. By the time of closest approach, our entire group had transformed into something between a scientific team and a circle of anonymous conspiracy theorists. By day, we wrote rigorous formulations. By night, we discussed why the tail of an interstellar comet had suddenly transformed into a strange, ugly, but increasingly recognizable soundtrack of humanity. We listened to fragments of old broadcasts, Olympics, wars, launches, heated radio discussions, and their reflections in the spectrum of the tail, and each time it turned out that there was a subtle but not accidental difference between the original and the echo. In some places, entire words disappeared, leaving only pauses and the announcer's breathing. In other places, on the contrary, moments of silence intensified, stretching out, as if someone wanted to emphasize what was left unsaid. At levels we usually dismiss as background, strange, regular repetitions of phrases emerged, cut out of context, as if someone were listening to our archives and distilling them for themselves. The creepiest thing was that the tale wasn't interested in everything. There was almost no trace of entertainment, music, or advertising in the millimeter range, but there was news, official announcements, space broadcasts, distress messages, codes, and call signs. 3I Atlas seemed to filter our signals based on the meaning we ourselves deem key. It was as if someone had told it, remember only what's important for history. Of course, no peer-reviewed paper can withstand the phrase, a comet prefers news to advertising. But the graph stubbornly suggested exactly that. And every time I turned off the monitors and laid my head on the table, I couldn't help but think, what if we're looking not at a comet but at an instrument? A device originally designed to pass by people like us, to collect, compress, and forward everything we've been shouting into space since the invention of radio. December 19, 2025 was strangely quiet. Official reports reassured everyone. 269 million kilometers is very far away, there's no real threat, and after the flyby the object will disappear into interstellar space. The news talked about a rare opportunity to observe an interstellar comet, showed atmospheric visualizations of a green tail, and confidently repeated, no danger to Earth. Not a word about how millimeter wave frequencies have devolved into a chaotic chorus of distorted voices from the last century in recent days. We sat in the control room, surrounded by cables and flickering indicators, and stared at the live spectrum. The tail was at its peak, the green glow was reaching its maximum, CO2 was boiling in all the lines, and on top of this hell of physics lay a second hell, an information hell. The scale flickered with hundreds of narrow spikes, many of which we could already recognize from memory. Here stretched a ridge of frequencies, reminiscent of an old television broadcast format. Here flashed the sigh of a numerical station, short like the click of a code. Then, for a second, the characteristic pattern of Voyager 1's bearded signal appeared, only with altered intervals, as if someone had played a familiar melody on an out-of-tune piano. And suddenly everything collapsed. Not literally, the devices didn't explode, the antennas didn't collapse. But the spectrum, which had previously been complex yet distinct, collapsed into a narrow range in just 2 seconds, as if all those voices, frequencies, and formats had been squashed into a single note. The power in this range increased so much that the security systems almost shut down the receivers. We somehow kept them in linear mode, and a moment later, instead of the usual staircase of noise and lines on the screen, a smooth, almost perfect curve remained. If you'd glanced at the monitors at that moment, you'd have thought we were observing something dull, like a maser. A clean, stable signal without oscillations, without randomness, without interruptions. But its internal structure was so dense that conventional analysis methods broke like plastic forks on concrete. We had to take a detour, looking not at the shape over time or frequency, but at the relationships of amplitudes between microscopic regions. I still have trouble describing what we saw there. In short, it was something that looked eerily like a compressed archive. Not in the zip file sense, of course, but in terms of its structure. Inside this note were all the same patterns: television, radio, space, only now they were folded together in a way we ourselves couldn't fold. It was as if someone had taken every radio signal Earth had ever emitted into space over the past 100 years, squeezed everything unnecessary out of them, and compressed them into a single pulse. The scariest part wasn't that it looked like an archive. The scariest part was that after 3I Atlas's flyby, this pulse never recurred. The tail cooled, the spectrum degenerated into the familiar molecular line tails, and we sat and watched the recording, realizing that we had just witnessed the moment when our entire technogenic history, all our cries into the void, were collected and packaged by someone or something that had whizzed past us at a distance of 269 million kilometers. Where this packet went next, we don't know. Our instruments are deaf in the directions and ranges to which it could have been redirected. Perhaps it remained in the comet's tail like an imprint, like a cast of civilization on a tiny interstellar rock. Perhaps it was ejected back into the darkness toward other stars, or perhaps, and this is the worst-case scenario, it was sent back to where 3I Atlas came from. As a report, as a summary, as a receipt. The official reports that came out months later were, of course, much more respectable. They spoke of unusual millimeter-wave tail radioactivity, of possible multiple diffusion of terrestrial radio signals on interstellar dust, of unusual plasma processes in the coma of an interstellar comet. No one mentioned that in internal chats we lowered our voices when we said the word archive. No one mentioned that some fragments found in the tail's signals still have no analogs in either past or present Earth radio streams. Sometimes I think all this is just an exotic form of echo, that 3I Atlas just happened to be in a region of space where the conditions for nonlinear reflection of our signals were perfect. They've created a terrifying picture out of random coincidences and strained correlations. It's easier to live that way and you don't ruin your career. But every time I hear an old jingle on the radio or stumble across a recording of that very same reading from the Book of Genesis from lunar orbit in an archive, that compressed, almost perfect pulse from the tail of a green interstellar comet flashes through my mind. And I catch myself thinking silly childishly, what if we're listening to a copy, not the original? What if somewhere far away the true original is no longer Earth, but the archive that 3I Atlas carried away? We've always believed that by sending signals into space we're making a statement. We're saying, here we are, here's our music, our noise, our mistakes, our laughter. We thought it was a one-way process. We speak, the universe remains silent. But on December 19, 2025, looking at the tail of an interstellar comet and how our entire radio biography shimmered in its alien light, I truly felt the opposite for the first time. Not that we were being answered, but that we were being recorded. And perhaps the most terrible thing here isn't that somewhere out there there's someone who needs this archive. The most terrible thing is that we have no idea which fragments of everything we've managed to shout into space over the past 100 years they deemed worthy of preservation. I thought that after 3I Atlas had run its course, everything would fade naturally, like after any spectacular cometary campaign. A couple of years of articles, conferences, a few documentaries, and the topic would dissolve into the general flow of space news. Instead, a strange aftertaste set in that refused to fade. We continued to live in a world where officially everything was as it had always been. A safe flyby, unique chemistry, green glow, interstellar origin, a priceless window into an alien planetary system. But in my world, the same thought still swirled around at night. We had just watched as someone unknown sorted and carefully packaged all of our radio noise for a century. And no one, save a couple dozen people, even suspected it had happened. After the flyby, the second wave of analysis began. We gained access to all the raw data from various observatories, satellites, and private receivers that enthusiasts had pointed toward the comet. Officially, we were doing the hard stuff, refining molecular lines, recalculating plasma temperature profiles, and estimating the dust mass in the tail. Unofficially, I had a separate folder on my hard drive in which all the anomalous fragments, the ones that didn't fit into any model, were neatly organized by date and time. Within these files lived clipped voices, fragments of old call signs, slanted, stretched, and jumbled into strange sequences. The most disturbing thing came to light when we began comparing data from different stations. It turned out that the anomalies weren't just a local effect of the receiving equipment. The same archived structures had appeared independently in Europe, Chile, Australia, and on private antennas in Japan. Different instruments, different calibrations, different operators, yet the patterns matched down to the last detail. This dashed any hope of blaming it all on my faulty scripts or the whims of a single telescope. Someone or something was indeed manipulating our radio noise in space, not in the electronics. One evening I received an email that made me sit up straight. An unfamiliar address, encrypted over encrypted. The subject line simply read Echo. Inside it read briefly, "You have the 3I Atlas tail, we have what came after, we need to compare." No signature, no institute affiliation, just an attached archive with another batch of raw data and a set of timestamps. Usually such things get sent to spam and forgot, but the timestamp strings looked eerily familiar. They lay atop our activity peaks, precisely coinciding with the moments when we recorded maximum signal compression. Only their source was different, not Earth, not ALMA, not an optical observatory. It was an old, forgotten coastal receiving complex that monitored deep space missions. We communicated in whispers, almost subterranean. It turned out that a group of engineers servicing the old deep space tracking antennas had decided to play around and reconfigured one of the systems to a mode no one had used in a long time. At the moment of 3I Atlas's closest approach, they detected a short but unusually powerful pulse, coming not from the comet's direction but slightly off to the side, roughly where, according to our models, the front of that very packet wave would have been if it had moved away from the comet, not deep into its tail but outward. It was a geometrically tiny difference, a fraction of a degree, but for interplanetary distances it was a gigantic corridor. We superimposed the two pulses, the one we saw and the one they received. The difference was curious. Our archive looked like a dense, compressed block, theirs like its imprint through thin glass. Some structures matched, some were blurred, and some were added. In these added fragments, we saw for the first time something that had never been seen before in any historical radio stream: sequences that didn't correspond to any human modulation protocol. It wasn't just foreign, it was like a subtitle to our own archive, a series of symbols inserted between our voices, as if someone had left a few notes in the margins during the packaging process. With this, the three of us couldn't stay alone in the dark control room. We had to go to those accustomed to working with more terrifying things. Every major organization has people who can look at the impossible without losing their official tone. We brought them our spectra, graphs, and overlays, and I was surprised to discover that they already had their own folder titled Atlas Anomalous. It contained reports from other departments, minor deviations in the satellite navigation systems during flybys, strange isolated glitches in some ground-based radars, and several cases of temporary desynchronization of atomic clocks on different continents. All of this, taken individually, could easily be chalked up to random errors, banal statistics. At any given moment, packets are dropped somewhere, bad frames are lost, power is lost, someone hasn't adjusted a filter correctly. But when we combined the time axes, they became mudded. Spikes in the archived signal from the tail, external impulses picked up by the old long-range antenna, micro-glitches in navigation, clock jitters, all of it combined into a single narrow time band, as if not just a radio signal had passed through our technological shell, but a wave that lapped every system sensitive to electromagnetic fields. No one could say whether this was a side effect or a purpose. In fact, that was the main fear. If we assumed that 3I Atlas was simply collecting an archive, then everything that was happening could be explained by an energy overload and complex plasma dynamics, like how a sudden solar surge causes a magnetic storm and at the same time electronic failures. If, however, we were to accept for a moment that collecting an archive was the primary function, then everything that was happening on Earth seemed like a test. A test of how deeply an impulse from outside could penetrate our systems. After that, the conversation ceased to be purely scientific. People who had never previously been interested in cometary activity began appearing at the meetings, people accustomed to thinking in terms of infrastructure vulnerability, information security, and critical systems. They asked strange questions. How easy would it be to embed such a pulse into the noise of the cosmic background radiation? How long would it take to detect it if we didn't know where to look in advance? What would happen if the same principle were used in reverse, not to read our radio noise but to embed something into it? At this point, I felt for the first time that our cometary story no longer belonged solely to astronomy. 3I Atlas had departed, the green glow had faded, the telescopes had turned to other targets, and its tail, not physical but informational, still hung over the planet like an invisible layer of questions. We saved all the data. We made backup copies in independent storage facilities with private groups on university servers, with those who weren't obligated to adhere to a unified reporting policy. Not because we wanted to hide it, but because we weren't sure that in a couple of years someone wouldn't decide to erase this history to avoid panic. Sometimes, when the night shift has a free hour, I run an old script, feed that same compressed pulse into the input, and let the machine search for matches with Earth's current radio streams. Most of the time, it returns zero. Modern digital communications are too complex, too fragmented, too heavily encrypted for random matches to surface easily. But occasionally, over long time series, something odd appears. A fragment of signal from a new satellite that unexpectedly rhymes with something in the 3I Atlas tail, or a localized interference pattern whose structure suspiciously resembles one of those interlinear patterns we saw in the pulse signature. I don't draw any conclusions from this. I simply file new coincidences in the same folder and label them with dates. Our work has long ceased to be an attempt to explain exactly what the comet did. Now it's more like a diary of observations of how long the aftermath of its passage will linger in our technological environment. How long after a single event will we continue to find foreign fingerprints in our own signals that we can't match with anything else? Sometimes I imagine 3I Atlas having already left the confines of the solar system and now hurtling through the interstellar darkness, carrying with it a dense, heavy lump of information. Mixed within it are the voices of announcers, mission codes, station numbers, distress announcements, SOS signals, and the curses of operators who never imagined their words would carry beyond the nearest radio horizon. Perhaps somewhere ahead on its journey, there's a place where such archives have been brought repeatedly. Perhaps there's someone there for whom we're just another collection of noise, no more interesting than we are to the spectrum of distant quasars. Or perhaps, and this is the most frightening thing of all, there is no someone there. Perhaps 3I Atlas itself is a mechanism, abandoned long ago in interstellar space without a master. A mechanism that mindlessly carries out a predetermined protocol, fly near a technogenic civilization, collect its voice, compress it, and send it on along an invisible chain. Then the question, who recorded us, is replaced by another, even more unpleasant one. How long has this chain been running, and how many such archives are already flying through the darkness, carrying alien stories to alien stars? We're used to thinking our telescopes give us the power to see far and deep, as if we were observers and the universe an exhibit. 3I Atlas, very calmly and without a single aggressive move, showed us the opposite. While we were aiming our optics at it, counting the kilometers and writing press releases about the green glow, someone in our observation orbit turned on a completely different camera. And now, floating through interstellar space is a small but powerful file in which we sound not as we would like, but as we have actually sounded all these years: loud, chaotic, desperate, often thoughtless. And when I think about it too long, the phrase, "the comet poses no threat to Earth," no longer comforts me, because perhaps the most real threat is no longer physical. We ourselves ensured that 3I Atlas had something to archive.